A very good evening, Dr. Zuri and Aya Razali. Today we are going to present about our group assignment. The first presenter is Lingeshwar Murugasu, the matrix number 203701. The second presenter Pavitran Mailwaganan, the matrix number 202731. And the third presenter Sudasan Ilango, 202461. Before we go to the problem, I would like to give the introduction about what is MATLAB. In pure mathematics, since MATLAB is an integral computer software which has three functions: symbolic computing, numerical computing, and graph drawing. MATLAB is capable to carry out many functions including computing polynomials and rational polynomials, solving equations, computing many kind of mathematical expression. One can also use MATLAB to calculate the limit, derivative, integral, and Taylor series of some mathematical expression. The equation of the function is dx over dt 37.5 minus 3.5x. The step value is given h equal to 0.1. With using MATLAB, the graph function with one or two variables can be easily drawn in selected domain. So the question is about what is the concentration of x of salt X at minute 1. The project background. The engineering problem that is related to Euler method. The problem is the concentration of the salt in a homemade soap maker is given as a function by time 37.5 minus 3.5x. The initial time is given as 0 and the initial temperature is 10 degrees Celsius. And the salt concentration in the tank is 50 grams per liter. By using Euler method and the step size given is h equal to 1.5 minute. What is the concentration after 1 minute 60 degrees Celsius? So to get more accurate, we change the step size into 0.1 minute. So the diagram shows the flow of the question where the initial is shown and the final when the t is 3 and the h is 0.1. Okay, the pseudocode. So we start the pseudocode with fix the step size with h equals to 0.1 and fix the initial concentration and make an array of time from 0 to 1 with the step size of h. So we use for loop with I equals to 1 and to n minus 1. In the for loop, we calculate the value of new concentration and we end the for loop. And we print out the new concentration, and by using the concentration and the concentration, we plot the graph against concentration against time, and we plot graph temperature against time, we plot graph concentration against temperature, and we plot a graph concentration, time, and temperature, and we end the pseudocode. So I'm going to give Pavitran will continue with script 5.
Okay, thank you very much, Lingeshwar. Now I would like to continue with script file. Okay, the first script file is based on the for loop and 2D plots. So for the for loop, we have to find the concentration of salt X at minute 1. So there's a given time and temperature in range. So time we set as a T, a small letter t, and temperature we set as a TEMP. So the equation is dx over dt equal to 37.5 minus 3.5x. Okay, let's into the coding. So the h, which means step size, is set to the 0.1. After that, the x, initial concentration, is set to 50, and then the number of iteration, which means n, equals to 11. So we have total 11 iterations. After that, we continue with time t equal to we put in a array format, so which means 0, and the step size is 0.1 until 1 minute. Okay, the temperature also is in an array method. Then it will increase by 5 until 60. So now we look into the for statement. The for statement is wrote by I equals to 11 and colon then n minus 1. After that, in the for loop, we write the equation of the Euler method, which means x I plus 1 equal to xi plus with h times 37.5 minus 3.5 times x, and we end the for loop. After that, we display the output, which means t, time, temperature, and the x according to each time and temperature. So after that, we look into the 2D plot for concentration of salt against time. Okay, we're using here subplot because we have three 2D graph. So the first subplot 311 plot tx, which means time against salt against time. So we set the title as concentration of salt against time, and x label is time, y label is concentration. So we include the unit also. After, the second graph is for temperature against time. So the subplot 312 plot is time against temperature, and then the title is set to temperature against time. The x label is time and the y label is temperature. So the third graph is 2D plot also for the concentration of salt against temperature. Okay, the subplot is 313, and then we use the plot statement, plot temperature x, and the title is concentration of salt against temperature. So we're using some font size here, 12 like that, and x label is temperature and y label is concentration. So the second is about the 3D plotting. So we use the script file also for the 3D plot, which means for the concentration of salt, temperature, and time. So this method is look like plot 3 in bracket using t, x, and temperature temp. So we set some line width, marker size, mark edge color, and marker face color also, and we type in the grid on, and then we x label is time, y label is concentration, z label is temperature of solution. So the title is concentration x and temperature against time. So now let's look into the output. So after we finish the script file, we run this program, so we get this kind of like output. So for the time temperature x, we form in a array method, which means 11 times 3. So the first column is about the time, and the second column is temperature, and the last is for concentration. So we see the last row for the 1 minute, the temperature is 60 and the concentration is 11.2432. So our objective is, this is the objective. So then the first picture is about the 2D graph. So we're using subplot, we can form the 2D graph in one figure, and the last picture is about 3D graph. So as just now. Okay, that's all from me. So now I would like to invite Sudarshan to continue with results and so on. Thank you.
Okay, thank you, Pavitran. Very good evening to Dr. Zuri and IR Razali. I'm Sudarshan and I would like to discuss on result and discussion now. Next. Okay, this table shows the output of time, temperature, and concentration of salt. As we can see here, when the time at 0 minute, the temperature was at 10 degrees Celsius and the concentration of salt was at 50 gram per liter. And that also shows that when the time is 1 minute, the temperature was at 60 degrees Celsius and the concentration of salt was at 11.2432 gram per liter. Next. Okay. So I would like to discuss on the graph that as Pavitran mentioned earlier. So this 2D plot, this graph shows that the concentration of salt versus time. So here we can see that this graph shows us a concentration of salt decreases with time. For instance, the concentration of salt was at 50 gram per liter when the time was at 0 seconds. When the time reached 1 minute, the concentration of salt was 11.2432 gram per liter. Next. So graph 2 shows that the temperature against time graph, and this graph shows that the temperature is directly proportional to the time. So when the time increases, the temperature also increases. For instance, when the time is at 0 minute, the temperature was at 10 degrees Celsius, whereas when the time was at 1 minute, the temperature was at 60 degrees Celsius. Next. So this graph 3 shows the concentration of salt and temperature. So this graph shows that the temperature against concentration of salt. The graph shows that the concentration of salt decreases with temperature. For instance, when the temperature was at 0 degrees Celsius, the concentration of salt was at 50 gram per liter. But when the temperature was at 60 degrees Celsius, the concentration of salt becomes 11.243 gram per liter. Next. Okay, let's discuss about the 3D plot. This graph shows that shows the concentration of salt, temperature, and also the time. So this graph is divided into 3 axes. The x-axis stands for concentration of salt, the y-axis stands for time, and the z-axis stands for the temperature. This graph shows that when the time increases, the temperature also increases, but the concentration of salt keep on decreases. For an example, when t was at 0 minute, the temperature was at 10 degrees Celsius, while the concentration of salt was at 50 gram per liter. But when the time reaches 1 minute, the temperature was at 60 degrees Celsius, while the concentration of salt decreases to 11.2432 gram per liter. So this interpretation of data from a graph is really helpful in solving an engineering application using MATLAB as a medium. Next. So in conclusion, the problem chosen has demonstrated the solution for application in engineering world by using MATLAB. So by using MATLAB, the problem was solved by finding the exact value of salt concentration at the given time, where the step size was fixed at 0.1. So this proves that the MATLAB helps a lot in the current world and could also be the backbone for new production in giant industries in the future. So that's all from me. Thank you.